totally taken out, but I didn't.
Hey, you washed it though?
Exactly.
Nice.
When?
I agree with all of that. Alrighty, my friends, let's last week of content for the most part. Like,
Scary.
what's that?
That's scary.
It's scary. Yeah, it is a little bit, right? Yeah. We'll actually probably, I think our final is Wednesday of finals week, right? Oh, look who's here. Oh, all right. Good to see you, my friend. Hold on, let's get this out of your way. Thanks. All right.
What kind of final is it gonna be?
Just over this stuff, not
Right in
cumulative.
class?
Hard.
Like right in the class?
Oh yeah, it'll be an in-class. Yeah. I think it's at a decent time of day, so like 10 or something, or 1. One of those two. We'll talk about it as it approaches. So yeah, final in 2 weeks from this Wednesday. We've got a few things to wrap up. Definitely I will not be presenting new stuff up through Friday of the week before finals. Right, we'll have some work days. I'll give you review materials. We'll have all that stuff in here. And I think right now, is there a web work floating about?
Yes. I don't know what's today.
One that opens today?
There's one already open and another one opens today.
Okay, cool. So there's one that's open. That is probably on the ratio test. Anybody have any questions on it? I guess that's what I'm really getting at. Is there anything you all want to talk about? No? Cool. All right, let's go forward. We're going to talk today about alternating series, and then I'm going to, in a little bit, a web work will open, and we'll talk about this, and then we'll work on the web work together. That's a good rhythm. Alternating series.
It's just on the floor.
One of the nicest series. Like when you have an alternating series, you should be happy, because this is really easy to understand and to work with, and maybe even understand what it's adding up to. So there's that as well. So first off, let's just talk about what we've got. We've got a series that, I'm not even going to put these indices here, but we've got something like this, or -1 to the n plus 1 e to the n. Either way, we've got something that looks like this. The key factor, am I recording, Gabe?
Yeah, you're good.
Thank you so much. The key factor here is I've got this alternation going on. This plus minus all the way through. So we're going to request a couple of things. We're going to assume that u sub n is positive. So that means the only thing that's changing sign is that -1 to a power. And this one, one of the two of these probably starts at minus, like this one would start at, who knows, -1, this one started at +1. I'm just trying to show here that it doesn't matter if it goes minus plus minus plus or plus minus plus minus plus minus, doesn't matter. So we're going to assume this. Then, and I'll show you what I mean by something that doesn't do that. Then if, we've got two conditions, u sub n has to die out. And when you have a series, an infinite series, and you want it to add up to something finite, the things you're adding up have to get smaller and smaller. So if this doesn't happen, then we know it diverges by something we call the divergence test, or the nth term test. The things you're adding up have to get smaller. But then this unique condition for this is that un is greater than or equal to un plus 1 eventually. What that means is that the non-alternating parts here, the things that are getting plus and minus, are shrinking in magnitude. So, in other words, u sub n is a non-increasing sequence. If these, basically three things here, right? I didn't put a number on the u sub n being positive, but if these things are all in place, the series converges. then we're going to do a couple subtle things with it too that are going to be kind of cool. So let's actually look at an example and then think about why this works. Because you can understand this completely. It looks a little abstract right now, but let's just take a look at an example. Let's take a look at this one here. So first off, I ask you, what does that series look like? So just to make sure you're like actively thinking, what does that series look like? And what does it remind us of? Because it looks like an old friend, kind of.
Series.
What's that?
The harmonic series.
Harmonic series, yeah, it looks like that, right? Except that it is alternating. Does that make sense? There, that looks like that. So this is called the alternating harmonic, not shockingly or very creatively either. So this is the alternating harmonic series. And we can actually add this thing up. And by next Monday, we will be able to know exactly what this adds up to. I'm going to tell you, this actually adds up to the natural log of 2. We can show that, and we will eventually. But this thing sums up to natural log of 2, which is like 0.7 or something like that. But you can get a calculator out and figure it out. But let's see, does this converge? And you know the answer, but let's apply our test. Step 1 is, yeah, it's an alternating series, so I'm going to apply the alternating series test, the AST. So since it is alternating, apply alternating series test. If you see an alternating series, don't worry about anything else. Apply this test. You might there's going to come a moment where your other things you know or we've talked about are going to come into play in just a minute, but straight up, I'm just going to apply this thing. So first off, what is U sub n here? What is that? Sorry. 1 over n. Yeah, it's everything except the -1 to whatever part. So we got that. Well, clear, that's all positive, right? So that's good to go. So we see that that is always positive when n is in the range of 1 through infinity. So we got that. We need to check these other things. Does U sub n converge to 0? So I ask you that. Are those terms dying? Yeah, getting lots. Yeah, they're going to 0, right? This is like the classic fixed thing over something blowing up. That's going to 0. So, yep. Checking on that. Is everybody cool with that? Does that make sense? Awesome. 2, the next one's a little trickier and a little bit subtle, and sometimes this is the one that blows things. But is U sub n non-decreasing? And I'm going to show you a cool way to test this. So first off, let's just look at U sub n versus U sub n plus 1. Let's just write those two things out. So U sub n is 1 over n, and U sub n plus 1 is 1 over n plus 1. Do we agree that this one's smaller than this one, right? Because the denominator got bigger, so the fraction itself gets smaller. So that's actually pretty easy to see, but it's not always easy to see. So we can do this, yes. In fact, it's strictly decreasing. It's just always shrinking, so that's awesome. But here's another way to see this. If it's not obvious, and this is about as obvious as they can get. If it's not obvious, use the first derivative. So in other words, take d dn of the U sub n. So treat the n like an x. Do calculus on this. And if
this thing is negative eventually, then the sequence is decreasing. U sub n is decreasing. So let's do that here. Let's actually crank that thing through. So here, the derivative of u sub n, notice how it helped to have that identified. Well, you could work this through, you could do this lots of ways, and you get that. Negative 1 over n squared. Does that sound believable? Yeah. I mean, think about this. I wouldn't do it like that. I would write it like this, n to the negative first, and then power rule it, and then that's pretty straightforward. Is this thing always negative? Yeah, right? It's 1 over a positive thing with a negative sign in front. That is always negative. So, always negative. So, u sub n is decreasing. I'll put that little arrow there. So that's another way to verify it. This means, so by the AST, alternating series test, this series converges. Isn't that lovely? But there's another thing when we have an alternating series. So you get this like pretty easy test to apply. And like frankly, friends, just like between you and me, and us here, and whoever watches these videos and such, this is probably always going to happen. If I give you a series and say use the alternating series test, this is probably going to always be. So, like, give me some loose argument, and I'll be one happy camper with that. This is the one that, you know, I really want to see you verify. But now you know how to handle this, for sure. So let's talk about the order of operations if we have an alternating series. So when you are given an alternating series, step 1 is use the AST to determine if it converges. Step 2 is see if it converges absolutely. See if the series converges absolutely. When what I mean by that is remove the alternation absolutely, i.e. remove the alternation and reanalyze. So when I remove the alternation here, I've got this. Here we get this series. Does that converge or diverge? What? What's your argument? So like, what kind of series is it, and? Okay, cool. So Boeing is saying that since this happens, the series converges. Do we have any counter arguments? Abraham?
All harmonic series where p equals 1 diverge.
Yeah. So that is a p series with p equals 1. That is the harmonic series. So that thing diverges. So remember, this can't tell you, Voin, but this can tell you if this happens, then it diverges. So be really careful. I'm glad you asked. Thanks. It's like I avoid $5 because we set that up ahead of time, so we can talk about that. It is in the mail. Here we get this, which is the harmonic series. Let's actually write this out a couple of ways. Harmonic series, and it diverges. So maybe you don't know it by name, but it's also, or it's a p series with p greater than or equal to 1. So it diverges. Less than or equal to 1. So it diverges. Remember P series, if you have this, those only converge when the exponent is bigger than 1. Gotta have a little bit of a power up there to get that thing going. Are we cool with that? Is this making sense? Yeah? So this series converges on its own, but it does not converge absolutely. So this series, we have a special word for that, does not converge absolutely, but it did converge without the absolute values being slapped on. In other words, the alternation being removed. So this is called conditional convergence. So let's just write that out. Since it converges as is, but doesn't with absolute value, i.e. absolutely, it is conditionally convergent. That's about all I want to say about that. But I want to show you something else once we know the thing converges. Like, how do we estimate where it's converging to? How can we figure out how much work we need to do to get that estimate? So we'll take a look. Let me let you get caught up here, because that's a lot of stuff. A nice, useful, fun fact that we might want to have up here, because this can knock out a lot of things. Note, if a series converges absolutely, then it converges normally. Then it converges normally. In other words, as is. This is a super useful thing, and you can use that argument. Let's take a look at an example of it. So let's look at another P series about it's -1 to the n over n cubed, n equals 1 to infinity. What is the absolute version of this? What's the absolute version of that series?
1 over n cubed.
1 over n cubed. So absolute version is just this. Does that converge? Does. How come, Scotty? You're right.
Because it's a P series with P greater than 1.
Solid. P series, P greater than 1, that converges. So this is a P series with P bigger than 1. In fact, P equals 3, right? We can be more precise. So it converges. Therefore, the original converges, and I'm done. So if this converges, this one just makes things smaller, right? Like if this adds up to something finite, here you're subtracting some stuff off. It's going to be just as finite. Yes, question, sir?
It was not a question, I was just amazed.
Oh, cool. Awesome. That's nice. Okay. So it converges absolutely. Hence, it converges as it is. And if you don't understand that argument, let me know. And I'm happy to say it again. Yes.
But is that always going to be true?
Mm-hmm. Absolutely. No pun. Bless you.
Thank you.
Let me give you one. Could you please do this one here? So we have sum n equals 1 to infinity of -1 to the n over the square root of n. Does that series converge? Does it converge absolutely? Those are the questions I'm asking. me give you two. We'll get another one up here. Let's do both these. Thank you, Bonnie.
Thanks.
Super
Just
cute.
cut it for me.
Very sweet. Oh, that's very nice. It's very cute.
Love it.
Yeah, I do too. I love bunnies in general. Oh, here's something. There. It's healthy.
Thanks.
Yeah. You're welcome. What do you think? Oh, you're going through that, sorry. Yeah. You thinking?
Let's take a look. Which one are we looking at? This guy here? Yeah. Good shit. Cool.
Yeah, absolutely. Yeah, solid. Got a conclusion there? Sorry. Oh, yeah, Is that okay? Yeah, it's okay. Yeah. Yeah, so, which is this? This is all the positive, cool. Okay, yeah, that's a nice argument, but there's one more thing you need to test, and that's the does it converge to zero? So just address that, even though it may be obvious. So, do you see what I'm saying? So that is that condition. So see, we have, you got that one, you just need to address that one, or check it. Do the terms die? What's going on out there? Slow dragging. Let's check in this one together. Identify the use of N. Clearly all positive. Is this true? Yeah. Fixed thing over something that blows up. Right. Square root of a billion, hella big. So, yep, that checks. Is it decreasing? Yeah, and Abraham had a nice way he wrote this over there. Let me just show you what he wrote. Just a simple, it was a real simple thing, but it makes it very obvious. It's a nice communicative device, right? Here, it just makes it so clear that the denominator is bigger, I think. I'd like to think. So I think that is like almost an obvious thing, but let's say it wasn't. Let's do the derivative. So alternate approach, just in case. There is one on your web work that's gonna open where it's not gonna be super obvious. So this was probably the route you want to take. So it's gonna be derivative of n to the -1/2, and look at how nice that's gonna be. You can see that's just negative 1/2 n to the 3/2, and that sure the hell is a negative number when n is a positive number, or when n is anything, because that isn't even defined when n is negative because of the square root. So then is decreasing. So this series by the AST, it converges. Does it converge absolutely? Does this series converge absolutely? Sophie, what you see? You're giving me like a real subtle no.
Well, because it's a P series and P is less than 1.
Perfect. So that diverges. Yeah, so when I slap on absolute value, so absolute convergence? Nope. Because absolutely, this is, and then we'll just write it out. That's P series with P less than 1, so it diverges. Is that making sense? Sound pretty good? Anybody done any work on this one here?
Just one quick question.
Yeah, go ahead,
If you
please.
are going through the steps and you find that one of them's false, can you just stop?
Done. Absolutely, yeah. That's a good question. Yeah. Scott, did you say you did a little?
Yeah.
What were you thinking?
Converges conditionally.
Cool. Okay, so let's go through. So yeah, help me out. So what's use of n here?
N+2 over N+4.
Beautiful. Looks hella positive.
Mm-hmm.
I like that. Okay, cool. Then what's the next thing you check?
Next thing, that diverges. U sub n.
So
That's what I looked at.
okay. So hold on. So what is is this the thing you did? The limit? Or is that the next part you did?
Yeah.
Okay, cool. So that's going to be limit as n goes to infinity of n+2 over n+4.
So 1.
Is 1. Yes. So that blows the test, right? We can stop right now. So because that's not 0, these terms don't die out. Essentially, when n is really big, you've got like +1, -1, +1, -1, +1, -1. So this series, we can stop right here. Stop. Diverges.
Yeah, that's why I asked if I had to.
Yeah, I gotcha. Does it converge absolutely? Hell no. Same problem, right? Same exact problem, absolutely. The terms don't die out. So here's a good tip. If it doesn't converge on its own, it's not going to converge absolutely. It cannot absolutely converge. So nice. Pretty slick test, right? Easy, well defined. You get a series, you know what to do. We got one last thing we want to talk about. 2 things. I want you to understand why these are so nice. I want you to have a little picture in your head of what's happening. And let's start with an alternating series that we've already looked at today, the alternating harmonic. So let's consider that for a minute. Let's think about the partial sums. So here we have the alternating harmonic. Let's look at the partial sum. So S1 is 1. S2 is 1 minus a half. S3 is 1 minus a half plus a third. You get the game. Let's make a picture. We don't often have pictures for these series, but we definitely can with these alternating ones. So let's plot out the partial sums on the real line. So the first one is 1. Notice that immediately I subtract something from that, and so I move to the left. The next sum is a half, but the key thing is I subtracted and I got to that half. And I subtracted something that's less than the thing I started with, less than the previous thing, because that's the decreasing condition over there. That's condition number 2. I'm always going to add or subtract something that's less than the previous thing. So that takes me to 1/2, and then I add on a third. So, ooh, that's not too much. So add on a third, moves to there, so plus 1/3 takes me to there. Let's see, so that's a half plus a third, that's, I don't know, 5/6 or something, 5/6. So that picture's pretty bad. If this is a half, then this must be like a third. There we go. I feel better about that. So that's plus a third. Then I'm going to subtract off a fourth. And when I subtract off a fourth, it can't take me further than I've already been to the left, because that distance is less than any other distance I've added or subtracted. So I go minus a quarter. And then I go plus a fifth. And do you see how I'm honing in on something? Each time our oscillation is less than the previous one because the terms are shrinking as we move out. So you're always moving back and forth, but each time less and less. So think of a pendulum just settling down to equilibrium. That's what's happening here. And the true value is somewhere in the middle of all those. So we can use the partial sums at any stage to understand where we're at. So like, check this out here. Let me actually summarize. At any stage of partial sums, the true value, like if you could go forever, if you had infinite time to add this all up, the true value of a convergent, it has to be convergent, alternating series, is between subsequent partial sums, any two partial sums. So, for example, between s sub n plus 1 and s sub n. And one of these will be bigger. It depends on if you started with plus or minus first. But that's why I'm being kind of vague about which one's less. But it'll be between these two. Can you believe that from that picture up there? Yeah, Scotty.
Do those two have to be in series with each other?
Yeah, yes, subsequent. Yeah, that's good. Actually, I think it's probably true no matter which two you pick, kind of just like thinking about that. Because no matter which one I pick here, it'll always be to the left of that. And whichever one I pick here, it'd have to be to the right of that, because of the way those things are going. So I think that probably any two.
What about 1 and 3?
But look at what the partial, so be careful, you're right, it's not between those two, but this, we never claimed it was, right? Because we started with 1, so let's look at this again. So we started with 1, and then we backed off a half, and we got to a half, and then we went up a third to there. So I'm not claiming that it's between these two. Oh, yeah, okay, I like it, yeah. Yeah, you're right, any two subsequent ones.
Okay.
There, yeah, yep. Good thinking, I like that. What's the difference between any two subsequent ones? So check this out. What is the width of the distance between any two subsequent partial sums? So let's put a but, because I'm very excited about this. But is s sub n plus 1 minus s sub n an absolute value? Can you help me out with that? Let's say our series looks like this. So our series looks like this.
negative 1 to the n or something like that over, sorry, negative 1 to the n times u sub n.
Well, let me help. Let me at least give you some guidelines here. So s sub n plus 1 is going to be, oh shit, this one starts negative, that's okay. So negative u sub 1 plus u sub 2 minus u sub 3, all the way out to, who knows how we end out here, u sub n plus 1. And then s sub n is basically that series just truncated a little early. I'll put minus plus there because it's going to be opposite of what that is. What happens when I take the difference in those two? Just that last term, right? Just the little bit, the difference. So when I subtract these two and I take the absolute value, I just get u sub n plus 1, the next term. This right here is the maximum error on our estimate. Using s sub n plus 1 and s sub n. That's the distance between any two subsequent sums here. And so it tells me if I can get that small enough, I can get the precision on my estimate as small as I want. So let me kind of write up what I'm saying, what I'm thinking here, and make it really clear. So here's what we're going to do. So plan to estimate this sum to within epsilon units of the true value. So what I'm going to do first, step 1, is I'm going to figure out how far I have to go out so that this window is less than epsilon. So to do that, I'm going to use this fact here. Choose n so that at the u sub n, the non-oscillating part, is less than epsilon. That the little bit you're adding on and subtracting off at the end is tinier than the threshold we've set. We'll do an example of this, but I want to give you an example in general first. Then find that s sub n. And this will be approximately the true sum to within epsilon units. So let's do this together. Because that might be a little vague. Oh shit, let's just go back to this dude. So let's come back here. Okay, so step 1. So let's see, estimate the true sum. We already determined it converges. That we know, converges, check, so I can do this. Estimate the true sum to within 1/100th of the true value. All right, I think I already said true, so I think probably that sentence is a better sentence right there. So estimate the truth to within 0.01 of the truth. So step 1 is I'm going to take u sub n, which is just 1 over n, that's the non-alternating thing. And I'm going to set that and then I'm going to set un plus 1, which is what I really need to do. I'm going to set 1 over n plus 1 less than 1/100th. So in other words, i.e., I'm going to set u sub n less than my tolerance. I'm going to solve for n here. Find the n that makes this true, then that means the things you're adding and subtracting are less than 100th. And so the truth is somewhere in that magnitude of where you're at. So set this here. and solve for n. How do I solve that equation? How do we solve inequalities with fractions?
Can you cross multiply?
Yeah, we can do that. We just gotta be careful, make sure nothing's negative. But yeah, that's great, cross multiply. N plus 1 over there, 100 up here. Or take the reciprocal of each side, but flip the inequality. So just make sure that when you're working with inequalities and you take reciprocals, you flip the inequality, right? Because we know that 1/10 is less than 1/2, but we know that 2 is less than 10. Right? So when you do that, you've got to flip it. So I'm going to solve for n. You go whichever route you want, Sophie's route or my route. You get the same damn answer. So n has to be greater than 99. So we'll say pick the next one right above that. Pick n equals 100. Now that's a shitload of work that we're not gonna do. But it tells you this thing is converging slowly to get pretty piss poor, pretty poor. I don't know if piss poor is a bad thing to say, whatever, it doesn't sound great, but to get pretty bad estimate. Like, you don't do work with estimates like that unless you're like building a compost pile in your backyard, you know, or something. And it's like, that's pretty good. Cut it right there. But if you're doing some real work, that's not tenable. So we're gonna pick n equals 100. So S sub 100 is within 1/100th of the true value. So I would, if we had access to modern tools, or not even that modern, like space age tools like Excel on this computer, I could show you that. But there isn't Excel on that computer for some stupid reason. Unbelievably. But this value right here, I wouldn't do this by hand. I would write some code to do this. Let's see, and then we'll be out of minus 100. If we could do that, that would be an estimate of the true value given infinite time, but be within 0.01 of the truth. So this is within, let's just write it again, 0.01 of the true value. That's all I gotta tell you today. We got a half an hour. We got a web work. A lot of this kind of stuff. Let's start working on it. Might even be able to finish it today, or mostly. I think it's due like on Thursday of this week. I appreciate y'all being here. I know it gets hard this time of year to come to school. You don't think? Well, you've had a breakation a little bit, but but you're here, doing it. Good work. I will do my classic walk to the restroom. I'll be back. There'll be questions. It'll be exciting.
is the partial sum of
Is
the
it just
first
like
four
what is
terms.
the value?
Yeah,
Okay.
absolutely. And then this would be S5. So just you literally just have to crank out, what that's going to be.
Okay.
It's not too bad, but then that gives you bounds on what the true value will be. Let's just go right here. Yeah. Sorry.
You doing good, Becky?
Yeah. Okay. Cool. You doing good?
Yeah, I'm just tired.
Yeah. How's
He had another surgery on Friday. So I'm gonna be there at least another week.
God? We'll have to get you more bunnies.
The doctor said he's the most complicated case he's ever seen.
Really?
I was like,
Oh, lucky! Wow.
Right.
Yeah. Can we get lucky on the lotto?
Literally keeps making me buy lottery tickets.
Because he's like luck like
I'm
this.
lucky.
He's like,
Yeah. He's like, there's a drawing tonight, go to Safeway. I'm like, okay.
Oh my God. I'm so sorry.
It's alright. We're getting through it.
Yes, you are. Yeah. Yeah. It's lucky to have you. You're good. You're good.
So what's your question? Yeah. So that's S4 and that's S5. Okay. Yeah. So just take this thing here and I guess subtract 1/5 factorial. Yeah, but that's the idea. Those two numbers, literally again, that was the thing I was talking about, that the estimate of the truth is between any two subsequent partial sums, so they just want you to copy them down there again. Okay. Does that make sense? Yeah, cool. Probably not gonna take complex analysis this fall then, because you have to take certain stuff, right? How's it going, Max? Good. Problem 3. You rocking it? Doing so good. Solid.
do you have a lot of troublemakers on your floor?
Yeah, somebody tore down the number signs, or the little signs that like the room number on them in West. Like they just went down and just ripped them all off the wall last night. It's like, why?
It sounds like typical dorm
This
shenanigans.
is someone's first time being drunk. It's like, wow.
I'm sure it's a lot of people's first time being drunk.
Yeah, it's the software dorms.
Okay.
Let's talk.
I'm just gonna walk you through this.
So what's S4? What does that mean?
Um,
What's that mean right there?
just be adding it all the way up to 4, right? So
Yeah.
what are we gonna do? One, or one, and then, oh wait, yeah.
don't need to put the -1 to a power, right? Because you know it's going to start flipping. So
Oh,
you could just go minus plus minus plus. Once you figure out what the first term is, it's just going to be opposite, right?
Okay.
It's going to alternate from there.
So. Wait. Oh no, that
That's
is
right.
right. Yeah.
Mm-hmm.
B minus right here, right?
Mm-hmm.
So I can just reduce these.
Yeah, exactly. Just one less thing to worry about. Yep. So that's first blank.
Oh, just put it all
Simplify it,
these.
just figure, I mean, just, yeah,
Oh.
do it, get it on a calculator and figure it
Okay.
out. And then this one is where you go up to 5,
Oh, so I just take this and
then
then add one
add,
more.
then subtract, 1 over.
So it'd be pretty much like, what, you would start at this one right here.
It would start at the same place.
It'd start.
It starts the same place, it just goes up one more. So it's literally this
Just one more.
with the next term kicked in. Yeah, it's gonna be a
Okay.
minus, yeah, exactly.
And you literally just put that into there.
That's the second blank. And then this is what I said in class, that the truth is always between any two subsequent partial sums. So you literally just take those numbers and put them down there again.
Oh, okay, I see.
Yeah, yeah.
So.
And then this is going to be the a sub 5 term, right? So this is that thing where I was saying that the truth, the distance between, let me write it on the board again, but true value is always less than the n plus first term, or use of n plus 1. So the difference between wherever you're at, like if you're at S4, so the difference between S4 and the true val of the series is less than the 5th term. Does that make sense?
That makes sense, yeah, thank
Cool.
you.
You're welcome. You're doing good here. You're good. Awesome. You doing good?
Yeah, I'm doing one from last week.
Oh, okay, cool. You good, Daniel? So, or this one's last week, I'll be right there.
So this is the using ratio test.
Yes, but that's not the terms. So let's take a look here, because notice that term, is it okay if I flip
Yeah.
this? So each of those terms is like a whole product, it's not just the thing at the end, right? So when we write out a sub n, so let's look at this, a sub n plus 1 times 1 over a sub n here. So we don't need absolute value either, right? Because there's nothing alternating. But a sub n is that thing that as written there. So if we add n plus 1 in there, so let's see 6 times 3 times 2 times. Now, what's written there is a sub n, so let's actually write that out. And then a sub n plus 1 is going to increase n to n plus 1, so that becomes 7n plus 1 minus 1 over. And same thing down here, but I'm going to replace n with n plus 1. But what I'm doing is also noticing, did I get that right? Yeah. 23. Is that, oh sorry, 8n minus 1, and this next term is 8n plus 1 minus 1. So this right here is just a sub n plus 1. Do you buy that? Yeah. Cool. And then we're going to multiply by the reciprocal of a sub n, which is literally just the reciprocal of that piece right there. So 7 times 15. It's pretty sloppy. But all the way up to 8n plus 8n minus 1. Boy, I'm sorry. That's pretty bad writing. And then 6, 13 up to, bless you, 7n minus 1. Now notice this stuff cancels with all this stuff, and you're only left with these last two terms. So this thing here turns into just 7n plus 6. You see what I'm getting at?
equals 7. Then I can take that limit.
Okay, and that just goes
Yes.
to 7/8.
There you go. Yeah, yeah. But I just wanted you to to see you were not, you were just looking at the end piece there, but it's that whole
Oh,
crazy
okay.
product. Does that make sense?
Yeah, I thought it was like, this was the, like
Yeah,
this.
yeah. And if it was just, if they had just written that without that product before it, then you would have been right on route.
Mhm.
But it would have also been inconclusive.
Yeah.
Yeah, okay, cool. Yes, sir. I figured it out. Oh, good job. Well done. Becky, how's it going? Got anything you want to talk about? Are you feeling okay?
So, I've been pulling pretty well, and then I'm just, everything struggling to find.
The pad, the
Yeah,
formula?
yep.
Okay, cool. So, let's do a first step before we get to there. Let's rewrite that as powers of 10. So what does that series look like if I'm just using 10 to a power? Do you see? Yeah. Yeah, yeah, exactly. Does that help maybe think about how we're gonna write that? Yeah.
Me too. I'm sorry. Would it be just
Yeah, it would. Yeah, if you're starting at 1, then that's perfect. Yeah, good move.
Okay.
And then there's gonna be a -1 on top also.
Yeah.
And it might as well also have n -1 as the exponent. That'll work.
Okay.
Does that make sense?
Yeah.
Okay, cool. Have a good one. Yes, sir.
Why is it different? This is last week's
Okay.
first one. Wasn't expected times.
Yeah, so what you've written here is not, it's just not, it's getting confused. So let's do a couple things. First off, take off the absolute value, because that's not really gonna play a role here, right? So let's get rid of that. And then, I would just put that k to the 7th on top of this, because I think it's getting confused and like not knowing if that's part of the denominator or what. So let's try that. Yeah, give that a shot. And then that part's probably gonna, no, that's actually, that's okay. Oh, it wants the limit there.
Yeah.
Okay, there you go.
It's gonna get
Yeah,
close to
perfect.
1 maybe.
It's gonna be exactly one. Nice.
That means this is-
There you go.
Awesome, thank you.
You're welcome. Still doing good? You got a question? Awesome. Yes, sir. Okay, let's see what you're thinking. Oh, so, let's see, this is number 6, right? On number 6, you're probably gonna wanna use a hand calculator or Excel or something like that. Let me do one kinda like that up here. Can I see that really quick, would you? Yes, sir. So yeah, on number 6, we've got a series that's like, and they want us to compute the number of terms to get this within some stupidly tiny tolerance. Okay. So what you need to do is use this condition here. So I want to get S sub n minus the true value to be
less than that tolerance that they gave me. Whatever, you know, you've got way more zeros in yours than I do, for sure. But Voin, you convert this into this. It's gonna be less than the non-alternating part here, n plus 1. So in other words, what I'm going to do is get out a calculator, or you know, if you're Excel savvy, this is going to be a lot easier. But just start taking this quantity here, and n has to be odd as well, and start just finding this value for larger and larger n until it's less than that quantity that I'm given. And then as soon as it falls under that tolerance, that's the n you need to use. Does that make sense? Yeah. So that's a tricky one that you can't do just with pencil and paper for sure. And we'll talk about it on Wednesday for sure. I got a feeling. Alrighty, my friends. Second to last Monday. Not bad.